Let's take a look at some solar-powered beacons. I'm not sure the exact application of these, but it implied they were for roadworks and things like that, although having done some tests on runtime and the solar panel, I'm not so sure I'd trust it for that. But we have this square base with the top held on with 4 screws, or in the case of this one, 3 screws. And we get a fairly decent cell inside, a solar panel on top. Well, I'll show you these operating and then we can open them. So I'll just change the lighting for that right now. One moment, please. So this is them operating, and I have to say it's quite odd because the LEDs point down the way into them, and also the amber-cased one also has red LEDs in it. So ultimately, it's just a red light inside an amber case. Okay, you've seen them operating. Watch your eyes, the light is coming back. So now you've seen them operating, we'll take one apart and we'll take a look at the construction. I've taken a peek inside. Actually, you know what? It's all right. The reason I've taken a peek inside is because I had to charge these with the power supply before making the video, because we didn't have enough sunshine today to put enough light in for them to stay flashing long enough for the before I actually started making this video. And there is no on-off switch. As supplied, they're flat. So to take them apart, you take the screws out, you lift the lid off, and then there's a very nice construction inside. The solar panel sits on top, then the circuit board, and then the battery. And likewise, when you're putting it back together, you just drop the battery in, lay the circuit board on, he said, fluffing it, and then put the little solar panel on. They could have doubled the size of the solar panels in this, but they didn't. Anyway, here is the circuit board with its red LEDs. I'll cover it over so you can see them flashing. There's not a lot of circuitry in this, but tell you what, I'll take a picture as usual, and then we can reverse engineer and explore it. It's not that complicated, but there are means to upgrade this if desired. Other things worth mentioning. They've soldered the connections onto these cells, and the cells in both of them had a different colour. I wonder if they're just basically salvaged cells. But anyway, I shall take that picture and then we can explore. One moment, please. The picture has been taken, the exploration has been done, and now we can explore the inner secrets. It's based around this rather anonymous little chip marked AA I or 1 small letter A. It looks like a manufacturing code. It's not exactly a chip number. There is the connection, the common connection for the solar panel and the battery, and there's also a test pad. And likewise, for the battery positive, there's also another test pad here, and that just means, I guess, they can probe it during manufacture to see if the LEDs flash on and off. We've got the solar panel connection here, 2 LEDs, a little 100 microhenry inductor, 10110 and a single 0 to give 100, and the chip, that's more or less it. Nice big LEDs. Let's take a look at the schematic. I've had to make a guess at the chip. It's not the correct pinout, but it has the same functionality. The schematic. There's a nickel metal hydride cell with the connections soldered on. It's not super high capacity. That's the first upgrade you could do, although ultimately you're probably going to have to solder wires onto the cell again. By soldering them on, they've got rid of that reliability issue of contacts. They've also kept it simpler, but ultimately you have to be very, very careful and make sure any solder connections are done fast onto cells. I don't usually recommend that because you can damage the internal chemistry by overheating it and potentially cause it to go into a little meltdown. But there is the cell, which can be upgraded. The solar panel itself here is a 45mm squared panel, but they've not used a lot of silicon on it. They could have doubled the amount of silicon just to actually increase the output. Presume this is designed for sunnier climates. The closest chip I could find is the classic YX brand, 8615. There's usually a letter after that. You can search for that yourself online. And it has the basic arrangement. It's got the power connection to the battery. It's got the solar panel input that is also used for dusk sensing, and the output to the inductor that is used to boost the voltage to the LEDs. There's also a mode pin. Normally in these chips, when that is taken high, it turns it into a static light, but if you take it low, it turns it into a flashing light. Quite often you'll find these horrible solar garden strings of lights that you can click the switch between 2 modes, flashing or static. Flashing is vulgar. It doesn't look good for those at all. The way this works, and I've explained this many times before, but I'll do it again just in case this is someone's first time seeing this type of circuitry. as standard, the voltage across the cell is 1.2 to 1.5 volts, and that's not enough to make most LEDs light. Particularly with the white LEDs used in solar lights. In this case, you've got two red LEDs, which do start conducting a fairly lowish voltage. If the solar panel is in really intense sunlight and the cell is fully charged, quite often the voltage will float high enough that these will start glowing, but it won't be visible in the bright sunlight. So the current can't flow through as standard because of the higher voltage LEDs. So what this circuitry does, when it detects dusk, it will shunt this connection down to the 0 volt rail, and that builds up a magnetic field in the inductor. When it disconnects, the magnetic field collapses and it adds on to the cell voltage, and that voltage is then high enough to make the LEDs light. So although they look static, well, flashing or static, they're actually pulsing at very high frequency with this pulsed inductor. Other than that, the only other thing that's worth mentioning is that the solar panel does charge the nickel metal hydride cell by an internal diode effectively, as well as the dusk sensing. And they also usually have the function that if the voltage drops to about 1 volt, it will shut down and it will go into a standby mode. I didn't measure the voltage across these as supplied. But they're neat. They came from AliExpress. I mean, where else? Everything's coming from AliExpress these days. I'll just shove that thing out the way. And I'll provide a link to them. They are fairly neat. Only available in this form in red and yellow, although I did get another one, and it doesn't just flash on and off at that solid rate. This one has a different chip that just pulses, quite an ugly unit, but with more silicon and with an on-off switch. Am I going to be able to show you this pulsing? There we go, that's it, it just pulses. That would have been better in these ones, but they've just used a standard garden solar light chip. This one appears to have circuitry that is optimized for longer runtime on a solar charge. But they are quite neat. The construction's quite nice. And they're certainly kind of like a usable, fun thing. They're not that expensive. But there we have it, the little solar post-top beacon lights, or cone-top beacon lights for square cones. They're quite novel, quite a fun thing to play with anyway.